Hello everyone. Welcome back. Let's start today with a curious thought. Have you ever noticed how the chairs in an auditorium are arranged row by row, each row starting just a little further back than the previous one? That small but equal increase is exactly what mathematicians call an arithmetic progression or AP. An arithmetic progression is simply a sequence of numbers where each new term is obtained by adding a fixed number to the previous one. If our terms are written as A1, A2, A3, and so on, then the condition is A sub k plus 1 minus A sub k equals D for all k belonging to natural numbers. This number D is called the common difference. For example, 1, 2, 3, 4 is an AP with common difference 1. Another example, 100, 70, 40, 10, this one decreases with a common difference of minus 30. And if all numbers are the same, like 3, 3, 3, then the common difference is 0. Isn't that neat? A sequence can increase, decrease, or even stay constant and still be an AP. Now that we understand what makes an AP, let's write it in its most general form. Suppose the first term is A and the common difference is D. Then the AP looks like this: A plus D, a plus 2D, a plus 3D, and so on. The nth term of an AP is given by the beautiful formula A sub n equals a plus bracket n minus 1 close into D. This is equation 1. That's it. If you know the first term and the common difference, you can generate the entire progression. Notice, ARPs can be finite, like only 10 terms of savings, or infinite, like the sequence of all odd numbers going on forever. So the power of AP lies in its simplicity. Here's a practical question. How do we check if a given list of numbers actually forms an AP? The rule is simple. Subtract consecutive terms and see if the result is always the same. Take the sequence 6, 9, 12, 15. Let's compute. A2 minus a 1 equals 9 minus 6 equals 3. A3 minus a 2 equals 12 minus 9 equals 3. A4 minus a 3 equals 15 minus 12 equals 3. Perfect. The difference is constant, so it's an AP with common difference 3. But here's a tricky one. 1, 1, 2, 2, 3, 3. The first difference, A2 minus a 1, is 0. The next difference, A3 minus a 2, is 1. Uh-oh, not the same. So this sequence does not form an AP. A small tip. Always compare at least 3 consecutive terms before deciding. Sometimes the first 2 can trick you. Now let's zoom in on how to find the common difference denoted by D. The formula is simple. D equals A sub k plus 1 minus A sub k for all k greater than or equal to 1. That's equation 2. Let's try it with the sequence 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2. Take any two consecutive terms. 1 by 2 minus 3 by 2 equals minus 1. That's our common difference. If D is positive, the AP increases. If D is negative, the AP decreases. And if D is 0, all terms are equal. So, the sign of D tells us the behavior of the sequence, almost like the direction of travel on a road. Let's connect APs to daily life. Imagine the heights of students standing in a queue, 147 centimeters, 148, 149, and so on. Each student is just 1 centimeter taller than the next. That's an AP. Think of winter mornings. Minimum temperatures recorded as minus 3.1, minus 3.0, minus 2.9. Yes, that's another AP. Bank loans also give examples. Pay back 1,000 rupees every month, and your balance goes 950, 900, 850, steadily down in AP style. Or consider school prizes. Class 1 gets 200 rupees, Class 2 gets 250, Class 3 gets 300, increasing uniformly in an AP. Even savings deposits work the same way. Adding 50 rupees each month makes your savings grow in AP. So APs aren't just in textbooks. They're all around us, in money, measurements, and nature. Time for a worked example to log this in. Suppose we are given the sequence for 10, 16, 22. Does it form an AP? And what are the next two terms? Step 1. Check differences. A2 minus A1 equals 10 minus 4 equals 6. A3 minus A2 equals 16 minus 10 equals 6. Excellent, the difference is constant. So yes, it's an AP with D equal to 6. Step 2. Find next terms. The next one is 22 plus 6 equals 28. The one after that is 28 plus 6 equals 34. Finally, let's check with the formula. A sub n equals a plus bracket n minus 1 close into D. If A equals 4 and D equals 6, then A sub 4 equals 4 plus bracket 4 minus 1 close into 6, which is 4 plus 18 equals 22. Verified. So the sequence extends as 4, 10, 16, 22, 28, 34, and so on. See how systematic it becomes once you know the rule? So let's wrap up our journey. We discovered that an arithmetic progression is a sequence where each term differs from the previous one by the same constant difference D. The general term is A sub n equals a plus bracket n minus 1 close into D. The common difference D may be positive, negative, or 0, giving us increasing, decreasing, or constant apps. We saw real-life uses in heights, savings, repayments, and even temperatures. And we practiced checking sequences and finding next terms with worked examples. Remember, once you know just the first term and the common difference, you can build the entire AP. And that's the foundation of arithmetic progressions. In our next lesson, we'll dive deeper into the sum of n terms of an AP, another powerful tool with real-life applications.